Okay, transformations of radical functions, right? This? The Pokemon Pikachu GS. We'll get into that later. Okay, the inverse of a quadratic function. The graph of y equals x squared is shown on the same. We're out. Are there any booklets around? Any spare booklets? There they go. It's like, okay. Right, you can't do one at a time here. On the same grid, accurately sketch the graph of the inverse of y equals x squared. So we know to take the point 0, 0, and it will become 0, 0. We take the point 1, 1, which becomes
1, 1.
We take the point negative 1, 1, which becomes 1, negative 1. We take the point 2, 4, which becomes 4, 2. We take the point negative 2, 4, which becomes 4, negative 2. We take the point 3, 9, which becomes, and by symmetry, my red graphs look much better than my purple graphs. Okay, so y equals x squared, this guy, is a function because what makes it a function? Yeah, for every x value, there's only one y value, right? So because each x value is, let's just say it's paired with only one y value. Paired with only one y value. Is the inverse of x squared also a function? No. How could we restrict the domain of the original so the inverse is a function? Yeah, so we could say x is greater than or equal to 0, right? We make that restriction. So x would be greater than or equal to 0. And basically you kind of look on the original graph and just say, if I can't draw a horizontal line, right? So I mean, anywhere above here, if I draw a horizontal line, it's going to cut. That horizontal line will become a vertical line right here. That will fail. So if I just start here at the vertex and go up then. Accurately draw the function with the restricted domain and its inverse on the grid shown. Okay, so the function with the restricted domain, I'm going to do in green. So it's really just going over top of this. Okay? And its inverse is only going to have positive values, right? There's no negative. Everything's positive here, so we'll just go and move that. It's blue. It doesn't want to do blue. So we'll just go in purple. Okay, I'm just going to darken that in a bit. So obviously if you have some pencil crayons, which by now you may have figured out is a good idea to have a few different color pencil crayons for doing all of these different transformations, then that would be a good thing. Okay, so we restrict domain. What's the equation of the inverse? Okay, so if we think about it, we have y equals x squared is what we started with. The inverse will be x equals y squared, which gives us y is equal to plus or minus root x. And we've decided that we're going to restrict it so we only have the positive values of root x, right? Not the negative. Okay, so we start with y equals x squared. We did the inverse, x equals y squared. We isolated y equals plus or minus the root of x, which was forgotten a number of times yesterday, and this became y equals root x because of the restriction on the domain. Actually, draw the, oh, I guess we're supposed to do it on this grid. Oh, well. Hopefully you did that. So it's this, and then it's this. So reflection in that. These actually kind of cross. Go forward. The basic radical function. Okay, so if you remember back to 20-1, we spent a couple of units on quadratics, right? So we start with the basic quadratic function, y equals x squared. What are all the characteristics? What does this look like? And then when I see it moved around and stretched, then I can say, oh, this was the stretch factor, this was this. Okay, gotta do the same thing with the radical function. So we need to start and introduce ourselves. What is the basic radical function? Y equals root x, the positive root of x, right? So since the square root, what can't we take the square root of? A negative number. So since the square root of a negative number does not exist in the real number system, the domain of y equals root x is, so x set of all x such that, so if we go formal, the set of x such that x is greater than or equal to 0. For y equals root x, complete the table of values below, sketch the graph of the function, and complete the following statement. Okay, so 1, it's just the positive square root, right? So square root of 1 is 1, the square root of 4, 9, and 16. Okay, and then we sketch that function. So we need to get to know this function, right? So it has a vertex. We call this the vertex, right? It has a vertex at 0, 0, which means the vertex is invariant under what? Under all stretches, under all reflections, and is only affected by the translations, right? So if the vertex moves from here to here, we know how it got there. It was translated. That's the only, right? Because it's not affected by any stretch. It's on all lines of stretch. It's on all lines of reflection, including the line y equals x, right? So it's not affected by a stretch or reflection. And then we say, if I move 1 unit above the vertex, then I move 1 unit. If I move 2 units, I go 4. Right? It's just like the quadratic, only with the quadratic we moved left or right a unit. We went up 1, up 4, over 2, up 4, over 3, up 9. Now it's up 3, over 9. Right? Quadratic, over 3, up 9, but this is the inverse. So up 3, over 9. All right? So if we want to tell a stretch factor, we should be able to tell, based on its graph, whether or not the radical has been stretched. Right? Based on go up 1, over 1, up, and so on. Now, really what you want to use for these is, if we give you a point on the graph, you're going to use that point. Don't imagine it goes through some other point. The only point you know for sure is when you see a black dot on there and you say, okay, I know it went through that point. I may use those coordinates to figure other stuff out. The shape of the graph is of a horizontal with a vertex at, where do you want to start? Vertex is at 0, 0. It's oriented how? So horizontal what? Parabola. And what chunk of a horizontal parabola? So it's half. So the shape of the graph is half of a horizontal parabola with a vertex at 0, 0. And the range is? So what are the possible y values? Greater than or equal to 0. So the set of all y such that y is greater than or equal to 0. Will a horizontal stretch change the range? Will a vertical stretch change the range? Will a reflection change the range? Could, depending on which one it is. Okay. Stretches can't change it, right? Because its y is greater than or equal to 0. Reflections can change it, because now it can go that way, or it can be down. Okay. Translations, for sure, may change it. I mean, depending on if it's an up-down. Transformations of the, so here we go, right back to the beginning, right? So we're hitting transformations again. This is why later you'll go back, look at that first test and go, right? Because we're going to go over transformations again and again on different functions. So all the transformations, including stretches, reflections, and translations, can be applied to radical functions. Use your transformation skills to complete the following. So for f of x is equal to -2, the root of x plus 1 quantity, then plus 4, state the transformations in the correct order. What do we do first? Stretches that were made to the graph of y equals root x to create the graph f of x is equal to -2 root of x plus 1 plus 4. All right, so if we want to think about this, we will say I started with y equals root x. I'm going to end, let's put it over on the left here. I'm going to do one transformation at a time in the order of doing all the stretches, followed by all the reflections, followed by the translations. And I'm going to verbalize them, although I'm going to write them down. So I'm going to write them down, right, and verbalize them as well, talk about it. So, what happened first? Are there any stretches?
Vertical stretch.
Vertical stretch by a factor of 2. We don't need to mention the axes. You're all stretch certified now. So, okay. Now, I could write y over 2 equals root x, or I can write y equals 2 root x. Any preference? Just go straight to the 2 root x. Okay. So instead, no, let's not. Let's just do it. So y was replaced by y over 2. This is a vs by a factor of 2. Okay, now let's simplify, right? So we're going to go write y equals 2 root x, okay? So we did it. Now let's just move it over. Okay, what else do we need? Are there any stretches on the x? No. Okay, what's next? Reflection. So negative y is equal to 2 root x, which will be immediately become -2 root x. And I'm okay if you just want to do this and then this. Okay, that's acceptable. I'm just going into more detail than may be required, but
Do we have to do any of that? Like,
you got to do this and this.
oh, okay.
Well, you got to
It just
describe
says
them. How are you going to
state the
describe them?
transformation.
Yeah, you think you're going to get it right. I don't. No, seriously, I don't. If I don't list them all, I don't get it right. So I need to. So just, I'm dumb. I need to do this. Humor me. You do it all at once. Be my guest, right? Just be prepared to get 0 out of 2. Okay? Like, I am seriously, I have to go one thing at a time. Okay? The only thing I can do at the same time is the left, right, up, down. I can do those together. I cannot do this if I don't break it out like this. I don't need to break this. I can go here and then here. But I do need to do this one at a time. I will never get that right. Okay? You think you will. Give it a shot. See how it works for you. What's number 2? So what do we got? Reflection in the y-axis. Yep. Peter, is that right?
Yep.
Reflection in the y-axis.
No, x-axis.
Thank you. So you're better than me. Okay, reflection in the x-axis. Okay, any other reflections? No. Okay, what's left? Okay, I am willing to do these both at once. Right? Because one's horizontal, one's vertical. So what else going on? So horizontal translation, left 1, and a vertical translation, up 4. Okay, and I could have written the y minus 4, but I'm starting to get away from that now. All right, so what did the question ask? State the transformations in the correct order that were made. Okay, so now we've got the transformations in the correct order. Use these to sketch the graph. Okay, so vertex, stretched by a factor of 2, where does it go? Same. Reflected, where does it go? Left 1 and up 4. Okay? So let's just take points that we can operate on, right? So if I had a vertical stretch by a factor of 1/4, then I would go here, right? I'd go to 16/4 because I can take a quarter of that. I might go to the 4/2 because I can take a quarter of that as well, but it's a little more awkward point. But 1/1 is good. Okay, well, vertically stretched by a factor of 2. Reflected in the x-axis. Left 1, 1, 2, 3, 4, up 4. Okay, so all I'm going to do is take each point, and the next point I'm going to do is 4/2 because it's a good point, right? Get a vertically stretched by a factor of 2, so it goes to 4, 4. Reflect, it goes to 4, negative 4. Go left 1, 1, 2, 3, 4. At this point, I had a small moment of panic. Watch out for the scale on these things, right? They're not always ones. Sometimes they're halves, so just be careful. Note the scale before you start doing anything. All right, let's do another point. So I've got 9, 3, which goes to 6, which goes to negative 6, and goes left 1 and up 4. It's going to end up at 2 here. Okay, because I'm just a smidge too big. So 4, 16, 4. Goes to 16, 8, goes to 16, negative 8, goes to 15, negative 4. Okay, at this point, I'm just mapping the point in my head, right? Just as we would do when we say state, right? We say state, we gave you that one yesterday, it said state the coordinates. So all it is like half mark for the x, half mark for the y. And then graph. Okay. All right. Use these transformations. Check. What's the domain? So, what's the start of the domain? Right, you can look at this too, right? Just say x plus 1 has to be greater than or equal to 0, so x is greater than or equal to negative 1. And let's use fancy domain notation. So negative 1 to infinity. Let's switch back to negative 1. And what's the range?
Negative infinity to 4.
Yeah, so the low value is negative infinity and the high value is 4. So negative infinity to 4. And it includes the 4, right? We got to go low to high, so we have to go negative infinity. The point, 25, 5, lies on the graph y equals x, right? Throw 25 in here, you get a 5. Determine its corresponding image point on the graph of f of x equals negative 2 root x plus 1 plus 4, and verify your answer. Okay, so I'm going to take the point 25, 5. I have the description of what's happening, right? So I got a vs by 2. So where does it go? It becomes what? So 25, 5 is 25, 10, 50, 10, 12 and a half, 0. 25, 10, right? Okay, vertical stretch was followed by a reflection in the x-axis. So 25, 10 is now 25, negative 10. Okay, so it's reflect in x-axis, right? Remember what happens? Y is replaced with negative y. 10 is replaced with negative 10. Okay, then what happened? Left 1 up 4, we can do those together. So left 1 takes 25, 2, and negative 10, 2. So left 1 up 4. So we have the point 24, negative 6, which is a point. Therefore, it's enclosed in parentheses. Say this is a point. Verify your answer algebraically. So algebraically, we are saying in this equation, so let's write y equals negative 2, the root of x plus 1 plus 4. If I take y as negative 6, then x should be 24. So negative 6 is equal to negative 2 root 25 plus 4. Negative 2 times 5 plus 4. And negative 6 equals, running out of room, negative 6. Throw a check mark in there. Yeah, this is a true statement. So that point is on this curve. Okay, so we have verified algebra. All right, so all we're doing is substituting in the point that we think we found. Right? Well, we didn't think we found. This is the point we got. Is it correct? Yeah, it turns out to be. Algebraically determine the x and the y intercepts. Okay, what's the easiest one to do? Y-intercept. So the y-intercept is f of 0. Right. Y-intercept occurs when x is 0. We're going to work out f of 0, which is negative 2 root 0 plus 1 plus 4, which is negative 2 root 1 plus 4, which is equal to negative 2. I mean 2. Okay, so f of 0, I'm going to replace that and just say y equals. Okay, so y equals 2. So f of 0 is y, which is equal to, or y, actually y is equal to f of 0 if you like. Okay, y is equal to 2. X-intercept, what do we do for the x-intercept? When you go negative 2 root x plus 1 plus 4 is equal to 0. We need to make y 0. We need to make this 0, right? I'm more comfortable with zeros on the right-hand side. You could write 0 equals, doesn't matter. Okay, so what do we do? Move the 4 over, divide by the negative 2. So we isolate the radical, right? Isolate the root. So this is 2. Square both sides.
Negative 2.
Negative 4 divided by negative 2, I think is possible.
Oh, never.
Square. If it were, then I know there wouldn't be an answer, right? Because I had it with a radical equals a negative. That's not possible. But when we square it, we would get an answer. Yeah. So x plus 1 is 4, so x is 3. Now, here's the deal, right? Had that been a negative 2, this still would have solved to x equals 3. We need to verify this. Because the act of squaring both sides can introduce solutions which aren't really solutions. Okay, so we need to verify x equals 3. Okay, so negative 2 root 3 plus 1 plus 4 should be equal to 0. Right? That's what we're thinking, that when x is 3, y is 0. So negative 2 root 4 plus 4 is 0. Negative 2 times 2 plus 4 is 0. 0 equals 0. That checks. Okay? But you need to check, because if this had been negative 2, actually this had been negative 2, you could have stopped here and said no solution. Right? Because you could have just said a square root cannot be a negative. Right? But if you had gone on, you would have ended up with this, and then you would have checked it and would have come out no. Right. But you should check. Okay. Again, the act of squaring both sides results in solutions which aren't solutions to the original. Okay, questions? We good? For g of x. You want to make any changes to g of x? Want to rewrite anything?
Yeah.
So what should we rewrite? So how should we rewrite it? Take out the negative 2, right? So you got to take out the negative 2. So I'm going to do a couple things. Instead of g of x, I'm going to write y. I'm going to move the negative 5 over to write y plus 5 is equal to the square root of negative 2 bracket what? X minus 6. I'm now going to verify what's in there. So I say I think it's negative 2 times x minus 6, which gives me negative 2x plus 12. Right? There were some problems on the first quiz with not verifying a factorization. So anytime you factor something out, quickly multiply it back in. Just make sure your signs are correct. That's likely where the mistake is. It's not like you know, or if it's a half, you likely doubled it, and, you halved it instead of doubling it. And if you multiply it back out, you'll say, oops, and you'll fix it, and it'll be good. Okay, state the transformations in the correct order. All right. So let's just write this again down here. So we got y plus 5 is equal to the square root of negative 2x minus 6. Okay. So, any stretches? Yes? What kind? So there's a horizontal stretch by a factor of 1. Okay, so hs by a factor. I know Melchek doesn't like it if you say hs. She wants you to write horizontal stretch. I'm lazy, so I'm okay with HS. Just don't write weird stuff. Like people write like VR or something. Virtual reality? No. Okay, are there any other stretches? No. Are there any reflections? Where? Where? You sure? Okay. Flexion in the y-axis. What's the order? So it stretches, reflections, translations. I always do horizontal first, but that's just me. So what is it? HT 6 right. And is there a vertical? VT down 5. I should have written 5 down. It would have been it would have been the same. I usually go direction first and then how much, but it doesn't matter, right? It's like how much which way or which way how much. Use these transformations to accurately sketch the grid. Okay. So I got the words. I now take the words and put them into action, right? So all I got to do is just do what it says on how many points, right? So we're working with 4 points here. Okay. Or are we? Horizontal by a half. Maybe I'll work on, so okay, 0, 0. Horizontal by a half. Stay there. Reflection Y. Stay there. Then what? Right 6. Which way is it? Down 5? Okay. Now, I'm going to do horizontal by a half. So if I do 1, I end up at a half, and that's just kind of awkward-ish, right? Let's do 4. So I got this point, 4, 2. Horizontal by a half, where do I go? 2, 2. Reflection on the y-axis. Oh, 2, 2 becomes what? Negative 2, 2, yeah? Right 6. So we go to positive 4, and down 5, we go to negative 3. Okay? So you can map each point. I mean, in essence, you could have wrote the xy mapping and said, it's like 1/2 x plus 6 and blah, and then just taken each point, applied the mapping to it, and just gone to its new point. I don't know. I'm just sort of, okay. 16, 4. Because I could do a horizontal stretch by a half, right? So I got 8, 4, which goes to negative 8, 4, which then goes right 6, which is negative 2, and down 5. So here. I don't know. Did I mess up, or is that the right point? Okay. I forget. Where did we start this thing? It started down here. Okay, so we are now going to sketch. It's enough to get an idea. How many points do you need to draw a curve line? More than 2. Straight line is straight. You could do other points. So let's say I just wanted to check that, right? And I said, what didn't we do? We didn't do 1, 1. Let's do 1, 1, right? Okay, so it goes to a half, and then it's reflected in the y-axis, so it's at negative a half, and then it goes right 6, so it's 1, 2, 3, 4, 5, 6, and then down 5, which is, yeah, about there. Okay, that's cool. Yep. No, there isn't one there. So why would there be one there? There's no asymptote for this original curve, right? So there won't be an asymptote. Like, use the, okay, I think we did that. What's the new domain? Start low, go high. Like so? Okay. Now you know that from looking at this, right? X minus 6 has to be greater than or equal to 0. So x has to be, if you move the 6 over, x has to be x minus 6. What? Oh wait, there's a negative in there, right? So forget that. So x minus 6 has to be less than or equal to 0, so it'll be negative, then that'll make it positive. Okay, so then x has to be less than or equal to positive 6. Okay, that's what we have. And the range? Minus 5 to infinity. So negative 5 to infinity. The point 36, 6 lies on the graph of y equals root x. Determine its corresponding image point on the graph and verify your answer by substituting. Okay. Okay, what was the first transformation we had? It was like an HS by a half. Okay, so where are we now? 18 and 6, right? Okay, then what? We reflected on the y. So where are we now? And then what? We could do the next two together because they just operate independently. So which way do we go? Do we go down 5, right 6? So right 6. Right, 6 takes me where? And what was it? Down 5? So negative 12, 1. Okay. Is that right? I don't know. Let's verify it. So I think this xy satisfies this equation. So I'm going to write y is equal to the square root of negative 2x plus 12 minus 5. I don't need the transform. As a matter of fact, I don't really want it, because if I take what I substitute into, which was wrong, then I'll get the right answer, which will also be wrong. If I go into this and this turns out to be wrong, I will then have a moment of cognitive dissonance, right? Because I'll be going, wait, it's not true, it's supposed to be true. At which point, leave that question, go on, finish the rest of the test, come back to it, and just say, okay, I made a mistake here. Because you'll waste 10 minutes at this point, right? You do not have those 10 minutes to waste. Go on, finish the rest, come back, and just say, no, there's something wrong here. If I have time, we'll look at it. Otherwise, leave what you got there, right? It might just be a half mark off. Okay, because you just made one little thing. Do not spend 10 minutes trying to regain a half mark. It's not worth it. Okay. All right, what did we say? We say that y is 1 when x is negative 12. So that, nice writing. Negative 2, negative 12, plus 12, minus 5. Okay. Make sure that stuff is where you want, like don't do this. Right, all of a sudden that's underneath. That is not underneath there. Don't do this. Well, maybe he'll think it is, and isn't. Either way, I'll get the mark because, no. Do this. Okay, got to be clear. So what do we got here? 36 minus 5. 1 is equal to 6 minus 5. 1 is 1. Right? And evermore shall be so. Algebraically determine the simplified exact values of the x and, again, the x and y intercept. Okay, so what do we do? Well, y-intercept is the easiest one, right? So the y-intercept is g of 0, negative 2 times 0 plus 12, minus 5, which is clearly not underneath the radical sign. Right? So y is equal to root 12. So y is, what's the root of 12? 2 root 3? So the y-intercept is 2 root 3 minus 5. Okay, notice, simplified exact value. Who wants to give me a decimal? No, you don't want to give decimal. Right? Okay, so it's 2 root 3 minus 5. And the x-intercept? So the x-intercept occurs when y is equal to 0. So we can write y equals. Okay, so 0 is equal to, so 5 is equal, I'm going to flip them around. Five. Okay, going to square both sides, right? Is that a negative or is that an approximate? Okay, and x is equal to negative 13 halves. Okay, which we should then verify, right? Because the act of squaring. Room to verify? Okay, so we're going to throw in, I think 0 is equal to the square root of negative 2 times negative 13 halves plus 12. The original one, right? Minus 5. So 0 is equal to the square root of, so this will be 13 plus 12 minus 5, which is root 25 minus 5, which is 0, and that does check. Okay? I think if we look back here, yeah, see, this is not asymptotic, right? It is going to go through. Okay? It's just going to go through, where does it go through? Negative 6.5. So not really a very good drawing, right? It should be passing through. So I shall adjust. There. Better drawing. Okay, and what did we say y was? Like somewhere just a little below -1 apparently. Okay. The graph of y equals 0 is vertically stretched about the x-axis by a factor of 4. So, horizontally stretched, blah, blah, blah. Okay, if I do a vertical stretch by a factor of 4, what gets replaced with what? So y is replaced by y over 4. Okay. I'm just writing those in just to tell me what to do. Horizontally stretched about the x-axis by a factor of 3. So what's getting replaced by what? 3x. Reflected about the x-axis. What's getting replaced by what? And then translated up 6 and right 5. So, up 6, right 5. Right 5, and up 6. Okay, write the equation of the transformed function in the form. So now we got to get used to this form for this equation. Y is equal to a root b bracket x minus h plus k. So a and b are stretches and reflections, right? So if a has a value other than 1, there is some sort of a stretch. And if it is negative, there is a reflection, right? But two different things. If b has a value other than 1, there's a stretch. And if b is just -1, then that's just a reflection. And if it's like -2, then there's a stretch and a reflection. Okay, so we just got to keep that in mind. All right, and we're supposed to write the equation of the transform function in that form. Okay, so let's start with y equals root x. That's what we're starting with. So I'm going to replace y with y over 4. And at the same time, I'm going to replace the x with the 3x, right? I can do both stretches because they're independent. One operates on y, one operates on x. And because I know I want to end up with this, I'm also just going to write y is equal to 4 times the root of 3x. Okay? So I've written it and now I've simplified it because I know what I'm aiming for, right? I want the y by itself. Okay, so check. Check. Going to replace y with -y. I'm just going to move the negative, so -4 root 3x. Okay, check. We're going to replace the x with an x minus 5 and the y with the y minus 6. So y minus 6 is equal to -4 root 3. Now, where I see x, I'm going to put down bracket x minus 5. Close bracket. Okay, so I've done these two guys. But I've got this stuck here. It needs to be over there. So y is equal to 4, the root of 3, x minus 5 quantity plus 6. Okay, and that's in the form y equals a, so a is 4, root b, b is 3, x minus 5 plus 6. Okay, yep. What's negative? -4, you're right. Well, it was up until negative. So if I looked at this, right? So if you showed me, here's my answer, right? Then I would say cover this up. I'm going to tell you what happened here, okay? So looking at this, you would say there is a vertical stretch by a factor of 4. There's a horizontal stretch by a factor of 1/3. There's a reflection in the x-axis that goes right 5 and up 6. And you'd look there and say, yeah, right? Just check each one of those off. Because that's what we should be able to do, right? Look at the transformed form of any equation and describe the transformation. So covering up what's there, if I just wrote that down again and then compared it to what's written there, this would be a check on a test, right? You do it at the end, you go back and check that and say, okay, this is what I think is going on. Yeah, it is. Okay, and if you discover that, oh, that's supposed to be a 3, and then you'll say, oh, that's got to be a 1/3. Okay, the mapping xy goes to 5x minus 6, negative y plus 7 was applied. State the transformations in the correct order that were applied. Okay, what's the first type of transformation that we do? We do stretches. Are there any stretches? Okay, so there's a horizontal stretch by a factor of 5 about the y-axis, if you want to. Okay, I'm going to leave off to why you're all certified in stretching now. So. Okay, are there any other stretches? Okay, are there any reflections? Where? So it's a reflection on the x-axis. So if I'm dealing with stuff, there's the two things we've just dealt with, right? Okay, what's left? What's left? 6. Yeah, it's left 6. And, yeah. So horizontal translation, which way? So minus 6. The 5x says exactly what it's doing, right? You take the x, you're replacing it with a 5x. You have stretched it by a factor of 5. It was a 2, now it's a 10. That's a stretch by a factor of 5. Okay, so we got a horizontal translation, left 6, and vertical, up 7. Write the equation of the transform function in the form. Okay, you know, I'm just going to go up here and I'm just going to do it right beside this. Because why not, right? The descriptions are there, so we'll just say go up here. So we start with this, y equals root x. How do I do a horizontal stretch by a factor of 5? So it becomes y is equal to what? Okay. Root of 1/5 x, right? We all look at that and we say, oh, horizontal stretch by 5. How do I reflect on the x-axis? Okay, so I'm putting the negative there, right? I'm tired of doing stuff on the left side, because it's just going to end up on the right side anyway, so, okay. And how do I go left 6? So where I see x, I replace it with x plus 6. And how do I go up 7? Go plus 7 over here. Okay? Plus 7 is not affected by that negative. Right? It's got to go up 7. So this says, like, do all this junk and then add 7 to it. That'll take it up 7. Right? Like, do everything here. So if you have an x, do this, add 6 to it, then do this, okay, and then add 7, and so you say, oh, ultimately I'm going to get some point and then go up 7. Okay, if you gave me this and said describe the horizontal stretch by a factor of 5, there's a reflection in the x-axis, goes left 6, up 7. Okay. Again, matches whatever's in there, right? For the what's the domain of this? Negative 6 and what? Okay, what do we know? We know that this must be true. There's no negative under here, right? So this expression has to be positive. So then x is, okay, so how does that work? Okay, what's the range? Yeah. So we say, where's the vertex, right? It's at negative 6, 7. From the vertex, it's going down, right? Because this is a negative, so it's reflected in the x-axis. So the range is as high as negative 7, so it's as low as positive 7, right? Sorry. It's as high as 7. Okay, and it's as low as negative infinity. Okay, we have now reached that moment in the course. Okay, so on the grid, graph y is equal to the root of 4x. So what are the words that go along with that? Okay, so this is, I just want you to graph an HS by 1/4. Okay? So on the left grid or the right? I want you to graph y is equal to 2 root x. What's that? Okay, on the other one.
It's not the same thing.
I don't know. Okay, they're the same. Why are they the same? Yeah, root 4 is 2, right? So you got y is equal to root 4x, which becomes y is equal to root 4 root x, which becomes y is equal. So a horizontal stretch by a factor of 1/4 is the same as a vertical stretch by a factor of 2. So, what does that lead to? The next page. Vertical, horizontal, right? A is vertical, B is horizontal. One hump? Not like an alarm, it's going to keep going. So, pick one and do it. Okay? So in other words, look at the graph, look at the transform graph, and just decide. So you say, oh, I can see pretty easily that this was vertically stretched by a factor of blah. Okay, cool, right? Because you know you can do either a horizontal or a vertical, right? They're the same, just one is the square root of the other. So a horizontal stretch by a factor of 1/9 is a vertical stretch by a factor of 3. Okay, so what's best to look for really is first, look and see if there was a reflection. If there was a reflection, it's either horizontal or vertical. Can't be both. So take the reflection and apply the stretch to it. So you're really only worried about one number. Either this is going to be like a negative whatever, or this guy is going to be a negative whatever. So look first and just say, hey, I can see that there was a reflection on the y-axis. Okay, that means the b is going to be a negative value. So then why don't I try and figure out what the horizontal stretch is? That will give me a b value. Okay. Your problem is going to come if you've got both reflections, right? So if you look at it and you say, it's reflected both. Okay, it means both of these are negative, and then I just have to pick one stretch. Doesn't matter, right? Like it's going to be a negative, and then what's the stretch that goes with it? Okay. So that's what you want to look for. Is start off, look at the graph, and say, was there a reflection? Yeah. Okay. Which kind? All right. So what have we got here? The graph of y equals root x. That's this guy. And another radical function, that's this guy. Determine the equation of the other radical function and express it in that form. Use a graphing calculator to verify your equation. All right, so was there a reflection? This goes right. This goes not right. So there's a reflection in the y-axis, right? All right, so then what are we going to try and do? So we could say, just here, observations, there's reflection in the y-axis. So what can I say about A or B? Which one? Right, so B is less than 0. Okay, so then what I want to try and figure out then is there a horizontal stretch here? Okay, is there a horizontal stretch? By a factor, it could be either, right? Yeah. And if you like, and you can just see the vertical stretch, then just do the vertical stretch and make your B negative. Either one will work. Okay. So you're coming up with an answer, not the answer. Okay? And what happens is, if your answer happens to have a 4 under here, and none of the answers have a 4 under there, but one of them has a 2 in front, then you could say, oh, that answer is equivalent to my answer because I can move the 4. Similarly, if your answer has a value out front and none of the answers, they'll have 1 out front, then you can put it under the radical sign. So if you have a 2 out here but nothing else, you just look and they're all 1s, move the 2 under the radical sign where it'll become a 4. Leave the x with its bracketed thing going on. Okay, so can we figure out a horizontal stretch? And if the answer is no, that's fine, we'll go with the vertical. So how would we figure out, how would we look and say there was a horizontal stretch? Okay, so normally, if I move up 1, I go over 1. Okay, so if we go up 1 and we're over a little tiny bit. Okay, so what made me go? It's like I went like up 4 and something and went over 1. Okay, maybe that's not so easy to find. If I go over 1, I went up 3. So what's going on then? If I go over 1 from the vertex, left or right, so normally I go here, I go up 1. So I went here, I went up 3. So there's a vertical stretch by a factor of 3. Okay, so let's say that. Well, we know there's a reflection in the y-axis, so we know that b is less than 0, and we know there's a vertical stretch by a factor of 3. So you just need to pick something that you can easily identify, right? Either a vertical or a horizontal stretch. Horizontal, not so easy to identify here, but vertically you can say, yeah. Okay. Normally I move to the right one, I've gone, now this is reflected, so I moved left 1, and I went up 3 instead of 1. Okay. So, right 1, up 1. Okay. In this case, because it's reflected, it's like left 1, up 1. Oh no, it's left 1, up 3, so it's vertically stretched by a factor of 3. Okay, we've got that. It's reflected in the y-axis, so we know b is less than 0. We'll make our b value negative 1. Okay, and we'll do a vertical stretch by a factor of 3. Okay, so there are no other stretches, right? You either do a vertical stretch or a horizontal. Okay, so we're doing a vertical stretch. We got all the stretches. We got all the reflections. What's left? The translations. What's the only thing that's this effect? This is affected by translations, right? So it's got to be right 2 up 4. So what else is going on? We have an HT right 2 and a VT up 4. Okay, so what were we supposed to actually do inside that blank there, right? Graph is determine the equation of the other radical function. So I've got all the words. But this has to go first now, right? This is number 1, this is number 2, these guys are 3 and 4. Okay, so we can start with, let's just go the vertical stretch by 3. Okay, so we start with y is equal to root x, and the first thing that happened was the vertical stretch by 3, so that's y is equal to 3 root x. Okay, I'm just getting it out of the y over 3 thing, just going to y equals 3 root x. Okay, then what? Then we had a reflection, so it's 3 root of what? Negative x, it was reflection on the y-axis, so negative x. Okay, then what? We went right 2, so y is equal to 3 root negative, and I replaced the x with? How do I go right 2? Minus 2. Okay, remember the form, right? The b is factored out. Okay, and then where do we go? Okay. So it's 3 root negative x minus 2 plus 4. So somebody looks at this and they say, you got 3 there. There's a vertical stretch by a factor of 3 going on here. Oh, I see a negative underneath here. That means there's a reflection in the y-axis. That says go right 2, and this 4 on the end. And this is the line. This is just a box around it. This line is not an extension of the radical sign. And then it goes up 4. Okay? Determine, that question is done now, right? Now we got number 6. Determine, so separate question. Determine the equation of a radical function in this form. Okay, so there's nothing horizontally going on, right? With a domain of 5 to infinity and a range of negative infinity to 8 and passing through the point 21, 6. So we can give you this info, or we could draw a graph, and we would put a solid black dot on 21, 6, which would be very easily identifiable. Okay? So the only points you know for sure are on a graph is if you can see the vertex is like 0, 0, or you see a black dot that says this passes through that grid intersection. Okay? Don't make stuff up. It won't end well. All right, so what do we do? Should we draw it? We could sketch it out, right? That would help, maybe. Do you want to sketch it out? Okay, I have a domain going from 5 to infinity, so it's going to start at, so somewhere along here is 5. And I have a range going from negative infinity up to 8. So where's the vertex at?
8. I mean, 8 and 5.
Or 5 and 8, maybe?
Yeah. I didn't say which was which.
Pointing right, or does it go right or does it go left?
Goes right.
Goes right, does it go up or down?
Goes down.
So it's got to go down because it's going to negative infinity, and it's got to go right because it's got to, so it's got to be this way and this way. Okay? But it passes through the point 21,6, so it actually kind of looks like this more. And then somewhere here is the point 21,6. So just a drop of 2. All right. Now what?
Do the equation.
Yeah, what do we know? Okay, so we just start off. Okay, so you gave me this, I will say. Okay, I know this. It's in that form. Now, which of those variables do I know?
H and K.
I know H and K, right? Okay, so what are H? So let's just fill those in. A root x minus 5 plus 8. Okay, so I know the vertex. HK is the vertex. I now have to figure out A, but they gave me an x and a y, so I can fill in x and y. Okay, so what's y? 6. What's x? 21. I always do this. I like I write the formula and I write this because that's my template, right? That just says your final answer is going to look like this, only you're going to have a value here. Okay, that you're going to fill in. So now let's figure out that value. This is that part of it. So this will be what? Negative 2 is equal to 4a. So 21 minus 5 is 16. The root of 16 is 4. Move that over. So a is equal to negative 1/2. Okay. So now I can write my equation. Y equals negative 1/2 the root of x minus 5 plus 8. All right, so I needed a little picture to kind of help me out. I knew there was a 5 and it was going bigger, and there was an 8 and that was the thing. Okay, now I got my vertex. Oh, that's HK. Okay, there's your vertex. Oh, and they gave me a point. Okay, fill it in. Where you go. What is that? The half. It's vertical stretch by a factor of a half. Or it's a horizontal stretch by a factor of 4. So the half comes underneath here, it becomes 1/4, right? I need to square it to get it under here. A quarter in front of the x, and it's going to be 1/4 bracket x minus 5. This is a horizontal stretch by a factor of 1/4 4.
Would you just add a restriction?
Would we add a restriction to that? Well, it gave us the domain and range, so I don't think we have to do anything further. Right, like the restrictions are there, and they're kind of built in. So at times, it doesn't hurt looking at this to say, hey, x has to be greater than or equal to 3/2. Okay, and that y is going to be greater than or equal to 5. Determine the, including any restrictions. Determine the equation, the inverse. All right. So actually, if we do the domain and range of the original function, we just flip them to get the domain and range of the inverse, right? So it doesn't hurt to, so what do we say? Well, 2x minus 3 has to be greater than or equal to 0. 2x is greater than or equal to 3. X is greater than or equal to 3/2. Okay, and what's the range? Well, this is a normal thing, and it's moved up 5, so, and then it goes up, because that's positive. Okay, so the range is y is greater than or equal to 5. Okay, so keep that in mind. That's the original, and then we flip it, so x is going to have to be greater than or equal to 5 for the inverse. But that'll become obvious when we do the inverse. So, what do we do to get the inverse? We interchange x and y. Okay. Hey. Thank you. Yeah, I was looking at the review quiz and was shocked by the number of questions on the review quiz that were so similar to the questions on the actual test. I'm sure you were as well. Anyway, so, okay, now what? Subtract 5 from both sides. Now what? Got to get y by itself, right? What do we do? Square both sides. I'm going to flip them while I do that. So 2y minus 3 is going to be x squared minus 10x plus 25. Now what? Add 3. So 2y is equal to x squared minus 10x plus 28. And so y is equal to half x squared minus 5x plus 14. We could complete the square on this and get that in vertex form, or if we wanted, right? But where's the vertex? So the vertex is at 3 halves comma 5, so the vertex of the inverse is going to be at 5 and 3 halves, right? Yeah. Okay, but this is what we want. Oh, and the restrictions, x is greater than or equal to 5. Has to be a restriction. And that's really the only restriction that's on that, right? I mean, okay.